Hi, on this video, we're going to take a look at the communicate questions on 257. But like the last couple of communicate questions that we've gone over, there's a really good work on it uh, lesson that you can do on your own at home, or you can do it with someone else. All you need is a flashlight, a large ball, and a smaller ball. So if you can use a basketball or a tennis ball and a flashlight, that would really be good to help you understand how solar eclipses work. So we're going to go through these questions assuming that you have done that work on an activity. So the first question is, what must happen to cause an eclipse of the sun? Draw pictures to help explain. So I hope you guys all have really good diagrams for this. For a total solar eclipse to occur, there must be an exact alignment of the Earth, the Moon, and the Sun, with the Moon casting its shadow on the Earth. So for that to happen, once again, we'll say the camera is the Sun. We'll say this is the Earth again, and this will be the Moon. So for a solar eclipse to occur, we have to have perfect alignment where this Moon is blocking the light of the Sun on the Earth. Now, total solar eclipses do not happen every month because the moon's orbit is not parallel to the plane of Earth's orbit around the sun. Now, solar eclipses do happen a couple times a year, but you only can be in certain parts of the world to see it. The last time we came close to a total solar eclipse in Saskatchewan was 2 years ago. Many of you use welding helmets to observe it, but it was only a partial eclipse in this area. To see the total solar eclipse, you would have had to have gone down to the corner of Washington State, and it kind of went across the United States at an angle through Washington State, Wyoming, and I think it ended in the U.S. On the coast of Florida. Okay, question number 2. What must happen to cause an eclipse of the moon? Okay, draw pictures to explain. So once again, everything has to be lined up very carefully again. So once again, the video camera is the sun shooting lights at the Earth. So we have our moon coming around, and for an eclipse of the moon to occur, it has to be blocked out by the shadow of the Earth, and sunlight can't hit it. Okay. Lunar eclipses are much easier to observe. They happen more frequently than a solar eclipse, and we can see them quite often in Saskatchewan. Okay, question number 3. Which type of eclipse would you notice the least? A solar eclipse or a lunar eclipse? Explain your answer. Well, if a lunar eclipse occurs, quite often we miss it. It's in the middle of the night. The moon disappears. We really don't notice it. But when a solar eclipse does occur, it is pretty noticeable. If you're in an area where you have a total eclipse, suddenly it turns into night during the day. It's very exciting. I would love to witness one directly myself. I've only seen partial eclipses in Saskatchewan. But just remember, if you are looking at an eclipse, even though the sun's partially blocked by the moon, you can still damage your eyes. Make sure you have glasses that are suitable. Regular sunglasses would not help you in that situation. You will still get damage from the sun's rays. Question 4. During what phase of the moon could an eclipse of the sun occur? Okay, so the only time that a solar eclipse can occur is during a new moon. Okay, so that's when we have the dark side of the moon facing us. So we'll say this is the side of the moon that we see during a full moon. So when it comes over here, it would be a new moon. So the sunlight would be facing the moon on this side, and we would not see any light reflected off the moon. So on the new moon, it's going to be blocking the Earth. For question number 5, during what phase of the moon could an eclipse of the, during what phase of the moon can an eclipse of the moon occur? Well, that's going to have to be during a full moon. So when we see the sun totally reflecting on the moon, and then when it comes behind the Earth, the light of the moon is blocked, or pardon me, the light of the sun is blocked by the Earth. And then as the moon moves, it will come back into the light again. Okay, question number 6. Draw a picture to show what you would see if you were on the moon looking at the Earth during an eclipse of the sun. So on that drawing, it should include like a dark, fuzzy, disc-like shadow crossing the Earth. Now remember, the moon is much smaller than the Earth, so its shadow is small and it wouldn't cover the entire Earth. So it'd be a smaller shadow crossing or going across the planet. Number 7. A lunar eclipse is longer than a solar eclipse. Give reasons to explain why. Well, once again, it's the shadow. The Earth casts a much bigger shadow than the moon does. So when the moon's going across the sky, it has to go across a much, much bigger shadow. So it's going to last a lot longer than a solar eclipse. Question number 8. How would patterns of eclipses change if the sun, Earth, or moon were different diameters or positioned at different locations? Now, the moon, the Earth, and sun have to be in specific positions for an eclipse to occur. So if they were in different positions, there would not be any eclipses. If the diameter of the sun and Earth and moon were different, an eclipse could occur as long as the three bodies were aligned correctly. Excuse me. If the moon was bigger, though, it would cast a bigger shadow, so our solar eclipses could actually be longer.